Okay, so two equations at once. We're just trying to find where they intersect each other. The first one is linear because every variable only has an exponent of 1. The second one, because there is an exponent of 2 on the variable, the graph will curve. And we know it's a quadratic equation of some kind, okay? We're still going to solve it the same way with the elimination method, or again, you're welcome to use Desmos and graph it. But for the elimination method, you cannot eliminate 2x and 2x squared because they're not like terms, and you don't want to multiply 1 by x, right? That would just make everything have an x variable. So we're not going to multiply by any variables, and we're still going to try to eliminate one of the variables. This is x and y. This is x squared and y. So we cannot eliminate x. It's in the wrong format. Okay, it's not common to both. We can eliminate y. So to do so, we're just going to take 2x minus y equals -4. I want to eliminate the y's. This is a negative y. This is a negative y. I can multiply this by a -1, right? And then that becomes a positive y. So that's what I'm going to do. Anything I do to this side, I also have to do to this side. So that becomes -2x plus y equals +4, right? And then that second equation is still right below it. And we're going to eliminate the y's. So we're combining these. 4 plus 0 is just 4. These are eliminated. We still have a -2x, and we have a positive 2x squared. So that was a positive 2x squared and a -2x that equal to 4. We can't, now we only have one equation, but we have an x squared and an x. We need to factor it now to find our two possible answers. Good. To factor it, or to try to find the two answers, we're going to set it equal to 0. So I'm going to subtract 4, subtract 4. 2x squared minus 2x minus 4 is 0. Good. Now this is just the same thing that we saw in previous units. We can use the quadratic formula, or we can try to factor it, whichever one looks easiest to you. Good. We can also take out a 2. If I divide everything by 2, then I get 2 times x squared minus x minus 2 equals 0. Make it even easier to factor. So now there's 2 on the outside. X squared minus x minus 2. The only factors of x squared are x times x, right? And the only factors of -2 are either -2 times 1 or +2 times -1, right? We want them to add up to equal a -1. So it's going to be x minus 2, x plus 1. Good. All right. Now I just find x by setting them equal to 0. That one doesn't have an x, so we don't need to include it. This is just x is equal to 2, and this is just x is equal to -1, right? So we have two different answers. We want to find points that they intersect. So we're going to take those x's and we're going to put them back into one of the two equations to find their y values. Does that sound okay? So I'm not going to use the one with the x squared. It's going to be easier to just use the one with a plain x. 2x minus y equals -4. Good. When x is equal to 2. 2 times 2 minus y equals -4. Sorry, this is x is equal to 2. So that's 4 minus y equals -4. Subtract 4. -y equals -8. Multiply by -1. Multiply by -1. Y equals +8 when x is 2. So that point is 2, 8. And then also when x is -1, 2x minus y equals -4. 2 times -1 minus y equals -4. -2 minus y equals -4. Add 2. Negative y equals -2. And y equals a +2, right? If we multiply by -1, multiply by -1. Y equals 2 when x is -1. So my next point is -1, 2. Okay. If you graph both of these in Desmos, you should find this point. They intersect at this point and they intersect at this point. I'm going to pause. Our next example is x squared plus y squared equals 4. And y squared minus x equals 4. Good. Again, I solved that using factoring. You're also welcome to solve it using the quadratic formula. It would give you the same x values if you use the quadratic formula. So we're looking for like terms that we can eliminate. The constant is the same here. The y squared is the same. The x's are not the same. Again, the x's are not the same. So it looks like the other one, except it's y squared. You are welcome to eliminate the y squareds. I'm going to rewrite it. X squared plus y squared equals 4. And then this one would be -x plus y squared equals 4. Everybody comfortable with how I rewrote that? I just gave this space and this space because they're not like terms. Again, we still need to make one of these a negative so that they will eliminate. We want to eliminate the y squareds, all right? So I'm going to rewrite it. X squared plus y squared equals 4. And then this is now -1 times a negative x is going to make it a positive x. -1 times a positive y squared is going to make it a negative y squared. So it's negative y squared plus x equals that +4 became a -4. Is that okay? All right. Now these eliminate. I just wrote it in a weird order because I did. X squared plus x equals 4 minus 4 is 0. Good. How can I factor just x squared plus x? I can remove one x, so I can divide them both by x, right? X squared divided by x is just x. X divided by x is 1. So instead of using the quadratic formula or more of a FOIL method, I just took out one common variable. The common variable was x. So now I have that set equal to 0 and that set equal to 0. Those were my two factors. I factored out the common factor of x, set that equal to 0, and then whatever was left, I also set that equal to 0. So that's just x is 0 and x is -1. Good. Now all it comes to doing is finding the y values. So x squared plus y squared equals 4, or y squared minus x equals 4. Y squared minus x equals 4. When x is 0. How about the easy one? Y squared minus 0 equals 4. Y squared equals 4. Remember when you were trying to eliminate that, you take the square root. Square root has a positive and a negative. Okay. So that cancels that. And we just have plus or minus the square root of 4. The square root of 4 is 2. So y equals 2 and y equals -2. When x is 0, y equals 2 and y equals -2. So that point's going to be 0, -2, and 0, 2. Now when x is -1, good. When x is -1, we're going to take that same one. Y squared minus x equals 4. Y squared minus -1 equals 4. Y squared plus 1 is 4. Subtract 1. Y squared equals 3. Doing the same thing as I did up here. take the square root, take the square root. When you're taking the square root, you have to include a negative and a positive. So y is negative square root of 3 and positive square root of 3. So that's going to be -1, negative square root of 3, and -1 square root of 3. They intersect in 4 places. Here, 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 and here. Okay, there's one more possibility you might encounter, and then it will let you go, okay? So here we have y squared minus x squared equals 4, and x equals y squared. Good. I have traditionally, if you look at what we've been doing, the constant's been on the right side. The constant's been on the right side. Here we don't have a constant. What I want to do is take that y squared and move it over here, just leaving 0 on the right side, okay? So if I want to line them up, I want my constants on the right, all my variables on the left. So this becomes y squared minus x squared equals 4. And this becomes, so I'm going to subtract y squared, subtract y squared. This is going to become negative y squared plus x equals, there's nothing over there, so I'm just going to call it 0. I left space for the x squared because it's not the same as the x. That, by moving it, I made it negative, thus canceling it out. Good. So those cancel. Negative x squared plus x equals 4. Good. All right. Now I have negative x squared plus x equals 4. What should I do? Which one does this look like? This looks like this one, right? Where we had a constant over here, an x squared, and an x. We have a constant over here, we have an x squared and an x. What did I do here? I tried to make sure I couldn't factor anything, factored out of 2, and then I just continued factoring it until I found 2 different x values. Good. There's nothing I can factor out here. It's not set equal to 0. So the first thing we need to do, just like we had over here, is move this constant to the left. And 4 also. So I'm going to subtract 4, subtract 4. Good. Negative x squared plus x minus 4 is 0. Good. All right. If you don't like your first term being negative, you can change the sign of all of them if you want. Multiply by -1, multiply by -1. Now I have x squared minus x plus 4 equals 0. Either of those is fine, okay? Now, is this going to factor? The only 2 factors of x squared are x. Is there anything that you can multiply to get a 4, but you can subtract to get a -1? So remember, you multiply to get a times c, or just to get c, and then you add to get b. My b is -1, needs to add to equal -1, and needs to multiply to equal 4. So the factors of 4 that would be negative would be 4, -4, -1, and -2, -2, right? Neither of those add to -1. So it's not really easily factorable, but we can do the quadratic formula, right? Quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac, good, over 2a. And right here, my a is +1, b is -1, c is 4, right? X equals -1 plus or minus the square root of -1 squared minus 4 times 1 times 4 all over 2 times 1. And this is just things we have done before in previous units. So that would simplify to 1 plus or minus the square. -1 squared is just 1 minus 16, right? Because 4 times 1 times 4 is 16, but we're subtracting it over 2. What is the problem? So x equals 1 plus or minus the square root of -15 over 2. We have done complex numbers where we where we can change this to the letter I. However, because we're talking about graphing systems, this number, this imaginary number, does not exist on the graph. The graph of x and y only has real numbers on it. The square root of -15 is not a real number. It's an imaginary number because it's a negative under the radical. So this, when you get here, you can just stop and say this is no solution. Good.